So in this course, we're going to try and introduce you to chemical concepts in the context of engineering. And so we set up these questions, and the first one is, why don't we build everything out of glass? And that's not as stupid a question as you might think, because glass is made out of primarily two elements, silicon and oxygen, and those turn out to be the two most abundant elements in the Earth and the Earth's crust. And glass is also basically the mineral quartz, and quartz turns out to be the second most abundant mineral in the Earth. So there's tons of glass around, and quartz is also the primary component of sand, and there's lots of sand around as well. So actually glass actually has some pretty appealing qualities in the fact that it's really cheap, and you can engineer a lot of things out of glass. You know, obvious things are windows, right? We all know that. But there's lots of other things, you know, glass bottles, containers, light bulbs, eyeglasses, cookware, then quite sophisticated things, you know, microscopes, cameras, scientific equipment, and glass is important, computers and smartphones and all this kind of stuff. So it's not just simple stuff, right? Complicated, you know, technological stuff is related to glass. You can even build large things out of glass, right? You can build stuff out of glass bricks. Here we have glass bricks and large buildings and so on. But you wouldn't want to build a bridge out of glass, would you? Well, actually, there is a bridge in China which actually has a glass bottom, right? So you can do an awful lot of stuff with glass, actually. This isn't a dumb question at all. But obviously, there's some material properties that engineers need which glass doesn't provide. And so, for instance, you know, glass can be strong, but it doesn't have a light weight, obviously. Glass doesn't conduct electricity. And this is where chemistry and engineering, you know, overlap. So if you're an engineer and you need a material which has a specific property, and you go look it up in a book, and there's no material has that exact property, then an engineer has to talk to a chemist, and a chemist has to design a new material, thinking at the atomic level. So building materials up, you know, at the atomic level. And what we're going to find is all material properties in principle can be linked all the way back to atomic structure and bonding materials. And this leads back to the most fundamental property of materials that chemists worry about a lot, is electrons and the nature of the orbitals electrons are in. And you've probably heard these terms before, and we're going to tell you all about this and remind you how all this works and give you more information about how electrons work and orbitals work and how that connects to stuff that engineers need. So yeah, chemists and engineers want to understand how and why materials have properties like this. You need to understand what's happening to the electrons. And almost everything we understand on the basis of electrons, and particularly, you know, their energies. And in order to get to that, both chemists and engineers have to embrace what's arguably the most profound and important theory of all of science, which is quantum mechanics. We're actually going to go back to quantum mechanics. Quantum mechanics can be very quantitative and mathematical. We take a more qualitative pictorial approach here, but without quantum mechanics determines what electrons do. Without quantum mechanics, we can't really explain anything to do with, you know, conventional atomic scale matter in the universe, and certainly not matter you need for engineering. But before we get there, we're going to take a quick look at some modern materials and see what they look like at the atomic level as our introduction to, you know, how do we think about matter, useful matter, and as a chemist and hopefully an engineer will also think about these things, like I say, at the real atomic level, because if we don't understand the atomic level, we can't understand the bulk properties of materials either, bulk properties we need to do all kinds of sophisticated things in modern society.